Welcome to today's exploration of the fascinating world of physical forces. Have you ever wondered how objects attract or repel each other? What's happening at the tiniest scales to make this possible? Let's dive deep into the heart of the matter and unravel the mysteries of the four fundamental forces. Firstly, to understand how forces work, we need to talk about force carrier particles. These are quantum particles that mediate, or convey, the force between objects. Think of them as the messengers that communicate the force's intent. 1. Gravitational force, the weakest of the four, yet the most familiar to us. It's what keeps our feet on the ground and the planets in orbit. At the quantum level, the hypothetical particle responsible for this force is the graviton. Though it hasn't been directly observed yet, the graviton is believed to mediate the gravitational attraction between masses. 2. Electromagnetic force. This force operates between charged particles. The force carrier particle here is the photon. When an electron, for instance, emits a photon, it transfers a specific amount of electromagnetic force to another charged particle. This can result in either attraction or repulsion, depending on the charges involved. For example, opposite charges attract because they exchange photons in a manner that pulls them together, while like charges repel each other as the photon exchange pushes them apart. 3. Weak nuclear force. This force is responsible for processes like beta decay in atoms. The force carrier particles for the weak force are the W and Z bosons. These bosons are quite massive, which is why the range of the weak force is so short. When certain particles interact via the weak force, they exchange W or Z bosons, leading to changes in their type or flavor. 4. Strong nuclear force. The strongest of the four forces, it binds protons and neutrons together in the nucleus. The force carrier particles here are called gluons. Gluons are exchanged between quarks, the fundamental constituents of protons and neutrons. This exchange of gluons keeps the quarks tightly bound together, ensuring the stability of atomic nuclei. Quantum mechanics perspective. In the realm of quantum mechanics, forces are described as interactions between quantum objects due to the exchange of force carrier particles. For instance, when two electrons come close to each other, they exchange virtual photons, leading to electromagnetic repulsion. These virtual particles are a mathematical tool that helps us understand and calculate interactions but don't have a real existence like other particles. Quantum field theory, QFT, perspective. QFT takes our understanding a step further. Instead of viewing particles as distinct entities, QFT describes them as excitations or ripples in their respective fields. Every particle has an associated field that permeates all of space. When particles interact, it's these fields that are interacting. Force carrier particles, like photons or gluons, are excitations in their respective fields that mediate interactions between other fields. This perspective unifies particles and forces into a single framework, providing a more comprehensive picture of the quantum world. Attraction and repulsion at the quantum level are all about the exchange of these force carrier particles. When two particles exchange a force carrier, they feel the force as either an attraction or repulsion, depending on the nature of the force and the properties of the particles involved. In conclusion, the universe operates on these intricate exchanges at scales far smaller than we can easily imagine. The dance of particles, fields, and force carriers is a ballet that choreographs the very fabric of reality. If you found this deep dive enlightening and want to explore more wonders of the universe with us, don't forget to hit that subscribe button. Together, we'll continue to unravel the mysteries of the cosmos.